Hello, welcome to the video solution for Edexcel Physics past paper. This is Edexcel IAL Physics, June 2019, Unit 4, and this is the part 1. So let's start. Question number 1. A nucleus of X 3069 emits beta negative particle. Which row of the table shows the proton number and the nucleon number of nucleus after beta negative particle has been emitted? So remember, if any nucleus which has a proton number Z and mass number A, and this particle is emitting beta negative, so the new nucleus, for the new nucleus, the proton number increased by 1 and mass number stays the same. This is a general expression for beta negative. Clearly you can comprehend, or you can see the idea. What if instead of beta negative, beta positive is emitted? So indeed the new nucleus would have a proton number one less, and then mass number stays the same. In this case, because beta negative is emitted, so this proton number increased by 1 and mass number stays the same, 69. So if you see, we cannot have a decreased proton number, either C or D, and in C, mass number or nucleon number stays the same. So option is C. A DVD is rotating at 570 rotation per minute. What is its angular velocity in radian per second? A typical question of Unit 4, even for a new syllabus, they give you angular velocity in RPM. This is revolution per minute, short form. They can give you in this form, and they ask you the SI unit, or converting the angular velocity in SI system, and which is a radian per second. So you always multiply the given number, multiply by 2 pi, because in one revolution we have a 2 pi radian, and we divide it by 60 because of the minute. If we have a revolution per hour, we divide it by 3600, 16 to 60. In this case, per minute divided by 60. So you do that, 570 times 2 pi divided by 60, and then answer will be 59.6. Of course, they give us a round of numbers, so 59.6 is 60. So answer should be C. Question number 3. Diagram shows a simple electric motor. The current in the coil is 0.4 ampere. The magnetic flux density is 0.7 Tesla. The length of XY is 5 centimeter. Which of the following gives the force on the side XY in Newton? So we need to find the force on the conductor XY, which is this, only that. And we need to find the force, and not only force, but we also need to find the direction, whether the force is acting upward or downward. First of all, we talked about force acting. So remember, force acting on a current carrying conductor is F is equal to BIL sine theta. But the conductor is perpendicular to the magnetic field, so this theta is in fact 90 degree. So sine 90 is 1. So force is BIL. Clearly, magnetic field is 0.07 times current is 0.4 times length, which is 5 centimeter when you convert into meter, so 0.05. This is the force. So if you compare, because we have just one conductor, so we cannot have a C and D. Just to confuse you, they times factor 2, because time factor 2 meaning force on 2 conductors, but we have just one, so either A or B. The thing is, we need to figure out the direction. In this case, you need to use Fleming left hand rule. So according to the diagram, if you see, magnetic field is acting rightward. This is the direction of magnetic field. And the current, according to the diagram, this is electric current. You can take, if you take positive current, suppose, then positive current is moving in that direction and it will go in the conductor and then from Y to X. Now you will have to adjust your left hand so that your first finger, for the first finger of the left hand is rightward in the direction of magnetic field. This is your first finger, and second finger should be from Y to X. As per diagram, just adjust the finger towards U. This is the second finger, which is direction of the current, positive current. If you do that, then your thumb will be upward. Thumb, and this thumb will give you direction of the force. So clearly, if you adjust your left hand according to this, remember YX, just visualize that conductor is in the direction of YX. That means the conductor is coming out from the screen or from the page, coming out towards you. So second finger towards you, so thumb will be upward. That means force is acting upward. So option is A. Question number 4. A kaon can decay in several different ways. Which of the following decays is not possible? So we need to find which of these is not possible. If you see option A, we are given a kaon, a neutral kaon. Generally we check charge, lepton number and baryon number. So if you see that left hand side we have a neutral, zero charge. On the right hand side we have a positive pi and electron, negative electron, so plus minus minus. So charge is conserved. Not only charge is conserved, but we also know that lepton is also conserved because we have an electron, and along with electron we have anti-electron neutrino. That's what happens all the time. So along with electron we must have anti-electron neutrino. So that means lepton number is also conserved. For option B, we have a neutral kaon, zero charge, but on the right hand side you see that we have a pi plus and pi plus. So charge is not conserved. That means B is not possible. So option must be B. And if you see C and D are also possible because we have a positive kaon, positive charge, and indeed if you see we have a neutral pi and electron neutrino, and along with anti-electron. So we have a plus charge after. So charge is conserved, lepton number is conserved, and we have a positive kaon, excuse me, and we have a positive muon. So charge is conserved, and along with the anti-muon we have a muon neutrino. So everything is fine except B. So option is B. Question number 5. When 2-point charges, each with charge Q, are separated by a distance R, the force between them is F. 2-point charges each with charge 2Q are separated by a distance 2R. What is the force between these two charges? So now charges, each of the charge is double, each of the charge, remember, and the distance is also double. So if you remember, force between two charges F initially, K, Q1, let's take it, so Q1, Q2 over R square. And now they are saying that each charge is double. So Q1 is double and Q2 is double. So K, 2Q1, 2Q2 divided by distance is also double, 2R whole square, and clearly 2 times 2 is 4, K Q1 Q2 divided by 4R square. 4 gets cancelled, and then you have a K Q1 Q2 upon R square, same as before. So there is no change in the force. So option must be C. Question number 6. The diagram shows the drift tube at start of a linear accelerator. This is a LINAC or linear accelerator. At the end of the linear accelerator, the drift tubes are the same length. Which of the following is the reason for this? In drift tubes or in LINAC, linear accelerator, if you see that tube length of the tubes keeps increasing because electron is speeding up. Electron is gaining speed, so that electron can spend equal amount of time. That's why the length of the tube is increasing. So if the length is not increasing, that means electron speed is not increasing. This is a typical situation if the length is not changing. So if you see the speed of the particle is no longer increasing. So question number 6, option must be D. Question number 7 and 8 refer to the following situation. An object moving north with a momentum of 23 Newton second collide with an object moving east with the 35 Newton second momentum. So we have a diagram, 35 Newton second east and 23 Newton second north. After collision, the object moves off together. Which of the following will give the magnitude of the final momentum in Newton second? It's a typical question of vector addition. Two vectors are acting or applying at right angle, then the resultant is found using Pythagoras theorem. So if we have a one vector A and one vector B, and they are acting in at right angle, so the resultant R can be found by Pythagoras theorem, A square plus B square root. So we have 23, we have 35, apply Pythagoras theorem, so option is D. Question number 7 or 8. So question number 8 for the same diagram. Which of the following gives the direction of the final momentum? We need to find the direction of the final momentum. So in order to find the direction, indeed, if you see according to given arrow, 35 Newton is acting there and 23 Newton acting upward, and then you have this resultant that you found and you need to find the direction. So clearly we cannot have option C and D. So we have arrow in this direction, so option A or option B, we need to choose the correct one because both resultants are acting in the given direction. But if you see, we are given this angle, and that means according to that angle. So if you see, this angle is as same as in this triangle the alternate angle theta. If you find theta in the triangle, then you will find that theta. Clearly this theta, this tangent theta, this theta you can find using tangent. Theta is equal to opposite over adjacent. So 35 divided by 23, and then tangent goes there. So theta is equal to tangent inverse 35 over 23. So okay, option is B. Question number 9. When a beam of high energy electrons is directed at a sample of crystalline material, electron diffraction can occur. Okay, yes, electron beam passing from some sample is screen. So we have a concentric circle at the center of the screen, and which is shown in this diagram. You see that this is a typical diffraction pattern. This can be observed as a set of concentric circle, fluorescent screen as shown. Now, which of the following changes would decrease the diameter of the circle? So decreasing the diameter, that means thickness of the strip should be less. Use of crystalline with smaller spacing, so smaller spacing, smaller d, so delta x will be okay. No, I will explain, just let me see. Use a screen further, capital, okay, now, yes, it is, option is C. Now, I'll just explain the reason. If you see, you can link the width of this, because this is a diffraction pattern, and if you just recall your concept of fringe width, I can just link, I'm just linking. We cannot apply that formula here, but because behavior is same, diffraction is there. So if you see fringe width, this is not the exact way, but in my opinion, this is, you know, a work here. So the fringe width, size of the fringe, delta x, depends on three factors, which is lambda, let me just recall, lambda d by d. So this lambda is the wavelength and capital D is the distance from the screen. You can link, and this small d is the spacing of you know, of the grid, like this. So this is d. So clearly the width is proportional to the wavelength. Delta x is proportional to the wavelength. Delta x is proportional to the d. Delta x is inversely proportional to the d. Now the first is use a crystalline with a smaller spacing. So if you spacing is smaller, d is less, delta x would be more. So we have a bigger circle. So we need to, you know, see which one will decrease it. So option A cannot be our option. Moreover, use electron for further from the crystal. So you increase capital D. If D is increased, delta x is increased. So of course it cannot be option. Option D, use electron with lower speed. Remember, we have a relation in this diffraction because we have electron wave. So wavelength of electron lambda is h upon mv. Sorry, it's not p, h upon mv. So if you decrease the speed, which is in denominator, so lambda will increase. So lambda increase, so width increase, circle will be thicker. So of course we cannot have A, B and C. C, option C, use electron with the greater momentum. You see mv is the momentum, so lambda is, you know, is inversely proportional to the momentum. Momentum increase, wavelength decrease. If wavelength decrease, then width decrease, so diameter will be less. So option is C. Question number 10. A ball has mass 0.4 kg and kinetic energy 9 joule. Which of the following give the momentum of the ball? So this is mass, kinetic energy EK or KE, whatever symbol you suits you, and the momentum is P, and you need to find the expression. So if you recall, there is a relation between kinetic energy and the momentum, which is kinetic energy EK is equal to P square by 2m, and P, if you make P as a subject, because you need to find P, so P momentum is equal to twice of EK into m square root. So 2 into kinetic energy, which is 9 joule, into m mass 0.4 square root. So you have option C. Question number 11. Calculate the electric field strength at a distance of 5 cm from the surface of a positively charged sphere. Diameter of the sphere is 12 cm. Charge on the sphere is plus 34 Newton Coulomb. Newton Coulomb, it's a nanocoulomb. So we have a sphere of diameter, this is the center. Diameter of the sphere is 12 cm. We have some point, let's say called P. We need to find electric field at point P, which is 5 cm from the surface. Clearly, if you need to find electric field due to a charge, so electric field E is K Q by R square. So in this case, this R should be distance from the center. In this case, this R should be 5 plus that much, which is 6. So 6 plus 5, which is 11 centimeter. This is your R, and you can convert this into meter, 0.11 meter. And then you substitute all the values. So E is equal to K is 9 into 10 to the power 9 into charge. Charge is 34 or plus 34 nanocoulomb, 10 to the power minus 9, divided by r square, 0.11 whole square. Once you solve this number, you have answer around 289.25 Newton Coulomb inverse. This is electric field. You can round it off. So 289, you can say 300 Newton Coulomb inverse. This is electric field. You can write answer here. So 25,300 Newton Coulomb inverse. Indeed, you need to find the direction of electric field strength. It is a positive charge. So positive charge gives you radially outward. So outward from the sphere. So you have a outward or radially outward from the sphere. Question number 12. A photograph shows part of a sculpture at the laboratories of the European Organization of Nuclear Research in Switzerland. This is some sculpture. A teacher on a tour says to a group of students, in fact, nearly all of the matter in that sculpture is made up of the two first generation quarks in combination called baryons and one type of a lepton. However, the matter is mostly empty space. Explain this statement. If you carefully read this statement, that all matter is made up of two first generation quark in the combination called baryon. This statement is talking about a structure of atom, because all matter, the basic building block of matter is atom. Atom is itself made of a smaller particle, but mainly matters are made of atoms. Atoms combined, they make molecules, or molecules make a large amount of matter. So atom is a building block. That's what you can think. An atom itself, inside the atom you have two protons, so you can visualize the nucleus. You have a proton and the neutron. An electron is revolving, orbiting around the nucleus. And now you see that proton consists of three quark. P consists of two up and one down quark, and due to three quarks, proton is called baryon. And the second neutron is also made of two down and one up quark, again a baryon. So that's what they are saying, that and both up and down, these are called first generation quark. So proton and neutrons are baryon, made of first generation quark, and electron revolving is a lepton. And you know the size of the nucleus compared to the size of the atom is very small, so atom is a mostly empty space. That's how you can link with this statement with the structure of atom, linking with the combination of quark and the lepton or electron. And you can write in that way. You can rephrase, you can rearrange as per your understanding. The existence of the Higgs boson was confirmed in 2012. The Higgs boson has no charge and a mass of 126 million electron volt per c square. Calculate mass of the Higgs boson in kilogram. A typical question. These students are quite lucky that they got this question for 3 marks. Sometimes same question comes in MCQs just for 1 mark. So mass is given 126 million electron volt. So how do you convert this unit, not this unit to kg? So you multiply it by 1.6 10 to the power minus 19, and you divide it by that number with the square of the speed. So 3 into 10 to the power 8 whole square, and then you can have your mass in kilogram. So 126 million or mega 10 to the power 6 multiply by 1.6 into 10 to the power minus 19. So we converted electron volt into joule, and divided by c square, which is 3 into 10 to the power 8 whole square. Once you solve this, so you will have an answer of this question around let me just do 2.24. so mass will be equal to 2.24 into 10 to the power minus 28 kilogram. This is the mass in kilogram. Part B. In a video about Higgs boson, the following statement is made. The Higgs boson can decay in many ways. Sometimes the Higgs boson decays into 2 high energy photons. Calculate the frequency of photons. Assume the photons are identical. Okay. So basically what is happening in previous part, we have a mass that we found 2.2 into 10 to the power minus 28 kilogram, and that mass converted into energy, because Higgs boson decaying, so producing energy, photon, and we can find energy by E is equal to mc square. Once we have energy, then we can use E is equal to hf to figure out the frequency. But remember, this is the mass of the Higgs boson that is producing 2 photon. So when you find the energy, so make sure that you have the energy. So let's find it. Once you do that, so E is equal to mc square. Mass is 2.2 into 10 to the power minus 28 multiplied by c square, 3 into 10 to the power 8 whole square, and then you have energy in joule, which is 2.24 into 10 to the power minus 10, and okay, and then 2.02 into 10 to the power minus 11 joule. This is the total energy from the Higgs boson, and half of the energy is producing 1 photon. So that means for 1 photon we take half of the energy. So E is equal to hf, and F is equal to E by h, and remember this E must be half of the previous, because we need to find frequency of 1 photon. So you can take half of that, 1.01 10 to the power minus 11, half of that value divided by h, which is Planck's constant. So 6.63 into 10 to the power minus 34, and then frequency would be equal to 1.52 into 10 to the power 22 hertz. This is the frequency of the produced photon. Part C. The video shows the following diagram, which represent the decay of a Higgs boson. The line are tracks of decay particles moving in a magnetic field perpendicular to the diagram. The video commentary includes the statement, sometimes Higgs boson decays into 4 electrons. Discuss this statement. 3 marks. So if you see the Higgs boson which was decayed, Higgs boson was a neutral particle. Neutral. And we see 4 track moving in opposite direction. So if suppose this, if I'm just assuming, if this is a positive charge going in that direction, that means it has, the opposite has to be negative, and if the upward is going, if positive, then downward has to be negative. That means we have opposite tracks. That means charge is conserved. So charge is conserved. That's why we have opposite tracks. Secondly, if you see the curvature, we have almost same curvature in opposite direction. And same curvature means, because magnetic field is same, curvature is same, that means their mass, their amount of charge, and their velocity, all these quantities are the same. So it is possible, if one is electron, then the opposite one should be anti-electron, and if downward is electron, then top one should be anti-electron. So we have 2 electrons and 2 protons. These direction I just assume. I did not use any left hand rule. I'm just assuming if one is electron, the other one opposite should be anti-electron. So of course it is possible that Higgs boson can decay into 4 electron, and this diagram is correct as per the explanation. So that's how you can explain. Question number 14. A student investigated elastic collision using an air track as shown. The friction between the gliders and the air track was negligible. So we have air track, glider A and glider B. Glider A has a mass of 0.5 kg and moved toward the glider B at a speed of 0.6. So this is velocity of glider A. Glider B was initially at rest, so the glider collide, and the velocity VA of the glider A after the collision was measured. After the collision, velocity of A is measured. The process was carried out for various masses MB. So MB is changed and keep A is collided with the same mass and same speed. The mass of initial speed of A and were kept same. The result are shown on the graph. So this is the graph showing by the results. So what are they doing? They are, send or glide the glider A, move the glider A with the same speed every time, with the same mass, and it hit the glider. And in the next reading, they change only the mass of the B, and then they move glider with the same speed and then hit the glider. So if you see the trend, what is happening, this is 0.5 kg, as same as MA. This is mass of the glider B. So mass of the glider B is 0.5, 1, 1.5, and so on. Now, if the mass of the glider B is less, then you see that the final velocity of A is positive. So it has some positive values. Of course, B is lighter compared to A, then definitely A will push the B in the direction of A. So B will be moving forward along with A with some velocity, and A also has some velocity. But if you see, if B has the same mass as the glider A, glider B is at rest. So when the glider A hits, then velocity of glider A is 0. That means glider A stops and B starts moving forward. And that's what the graph is showing. And after, as the mass of the glider B increases with respect to, increases compared to A, then the A start bouncing backward. That's why we have a negative velocities going downward for, for glider A. This is just explanation for the graph. That's how you can see. Let's go to the question. Part A, describe the motion of the glider A and the glider B after the collision, and we have 3 different scenarios. So scenario 1, if mass of B is greater than mass of A, mass of B is less than mass of A, so A is heavier. So you can imagine this is a smaller mass and you have a bigger mass and it is coming. So of course when the A will hit B, then both particles will be moving in the same direction. So B would have a velocity and after collision, and A would have some other velocity, and both will be moving forward. So that's how you can see, and that's what graph is showing. Both A is moving in the same direction, so you have a positive velocity if mass of B is less. When mass of B equal to mass of A, this is the situation. So when glider A hits, then A stops because you have a 0 velocity, A is not moving. And but B gains all the momentum from A and it starts moving forward. When mass of B is more than glider A, then after hitting, glider A bounce back, moves leftward, and B starts move forward. Part B, calculate the velocity of B, VB of a glider B after the collision when MB is equal to 1.4 kg. Do not assume that the collision is elastic. So whether we have elastic collision or inelastic collision, we always use law of conservation of momentum to find the velocity during collision. And momentum is M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. It's your choice whether you take U1 initial velocity or V1 initial velocity, regardless, or you can flip it. Flip the formula is fine. Generally we take this is initial velocity, so M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2, and we need to find velocity of B when mass is 1.4 kg. That means we need to look for the graph. So when mass of B is 1.4 kg, which is 1.4, if you see 1.4 is we have a 0.02, 1.1, 1.2, 1.3, 1.4 is this. This is 1.4, and then your corresponding velocity is this. This is 1.4. This is 1.4, and then corresponding velocity you can find from here. And this velocity, if you find 0.5.02, so minus 0.2, 0.22, 0.28. So this is minus 0.28 meter per second velocity of A after collision. Now, so before collision, we have a mass of glider A 0.5, moving with velocity 0.6 rightward. After collision, and we do not have any, M2 U2 is 0 because glider B is at rest before collision. So this is M1 U1 equal to now M1 V1, final momentum of glider A. So 0.5 times velocity of glider A, which is minus 0.28, and B will be moving forward, so plus MB, which is 1.4 into VB. That's what you need to find. So this is law of conservation of momentum, and you can make VB as a subject. If you make VB as a subject, then VB would be equal to 0.31 meters second inverse. This is the velocity of B. Determine whether the collision was elastic when MB equal to 1.4. So we need to find whether the collision is elastic or inelastic. That means we need to find total kinetic energy before collision and the total kinetic energy after collision. So before collision, we have only one particle moving. Before collision, we have one particle moving, which is A. So half 0.5 into 0.6 whole square, half mv square, kinetic energy of glider A before collision, and this value will be 0.09 joule. This is kinetic energy before collision. Now let's do after collision. So after collision, both are moving. After collision, both gliders are moving. After collision, so we have a kinetic energy of glider A, kinetic energy of glider B. So half of 0.5 into 0.28, because we are calculating kinetic energy, so we don't need to take negative sign, because kinetic energy is a scalar. So half 0.5 0.28 whole square plus energy of glider B, half of 1.4 into 0.31 whole square. Once you do this calculation, your answer will be 0.087. Of course, you can round it off, approximately 0.09 joule. Indeed, you see the kinetic energy is same. So kinetic energy before collision is equal to kinetic energy after collision. So the collision is elastic. You need to write this statement. Thank you very much. I hope you understand. We'll see you in the next part. Have a nice day.